Hi there. My name is Aaron Lanterman. I'm a professor of electrical and computer engineering at Georgia Tech. And as yet another example of doing PCB layout in Eagle, I'll take a stab at the Buchla 257 dual control voltage processor. So this takes 3 voltages in. One of the voltages gets multiplied by a scale factor set by a knob. Two of the other voltages, VB and VC, I think it crossfades depending on another knob, this M knob. And you can also add some offset and get an output. Now, in Buchla systems, there's a strong distinction between audio signals and control voltages, and you can debate the pros and cons of different approaches to that. One thing I'm not particularly fond of in the Buchla style is that the control voltages are only positive, so it kind of makes sense to me that you should let those go negative, although a lot of modules will actually either not just be, they won't just be tolerant of negative voltages, they seem to respond in a natural way. But in any case, this one, I think when we see the schematic, you'll see there's a bunch of instructions for 0 to 10 volt CVs. And I think the default setting of the schematic is 0 to 15 volt CVs. And I have dreams of eventually picking up some 200E modules, and that's a 0 to 10 volt. So I'll set this up with a 0 to 10 volt style. Anyway, I'm starting here with a template that I've renamed B257. This template I have up here on my GitHub, Lantertronics GitHub. You can go find this. There's the ACMS project starter template, and that's what I have here. I also recommend downloading these Aaron libraries, and the libraries that have the upgrade suffix are not ones I made. They are, however, libraries that did not seem to import into the newest version of Eagle until I tweaked one of the lines. So for the benefit of my students and whoever else, I made a version of these where I tweaked the line. So hopefully these will load into the newer version of Eagle. I just want to emphasize that I didn't create these. But the ones up here, well, these are modifications of things in the Eagle library. All right, so let's start here. We're going to first delete all the Eurorack stuff. Let's see, can I group all of this? And then maybe then I can pull out the trash can. Can I hit the delete key? Oh, did that work? Oh, that worked. All right, we're into modern civilization now. How awesome is that? Let's see. Get rid of this. I've got my power stuff up here. I'll go ahead and put in some bypass caps because I know I'll need those eventually. So the 10U here is to go near the front of the connector. And let's see. Sure, we have some bypass capacitors here. Let me go ahead and rename some of these. I'll name this C100, C101, C102, C103, C104, C105. All right, and let's take a look at the actual schematic and see what we're going to be arguing with here. All right, so let's go over to the FluxMonkey site and take a look at the take a look at the schematic here. Oh, here's a third order Salin key. Wait, nope, not a third order Salin key. That's just a second order Salin key. This is a complicated stuff. Okay. So I've got ton of filtering going on. And the reason we have a ton of filtering is the way this circuit handles voltage-controlled amplification is very different than what you would use vectorals for, or a FET as a variable resistor, or something like an SSM 2164 or that whatever voltage-controlled amplifier chip, or something with an OTA. What this circuit does is it's basically what's called a chopper. It essentially takes the signal that it wants to modulate by some sort of control voltage, and it flips it on and off. It basically has a switch, turns it on and off at a very high rate. And it's like a PWM output on a microcontroller. By changing the duty cycle of that process and then filtering the daylights out of it on the other side, you can accentuate that voltage-controlled amplification. Or in the case where you're cross-fading between two signals, you can switch between the two signals, again, at a super high rate. So this one, I think he writes 21 hertz. So that's not so that wouldn't be something you could do with audio signals, which is why this is for control voltage. I think Mark Verbos has a post on his Buchla Tech blog talking about this, where he talks about designing a version of this, a modern version with a much higher switching rate that you could actually use with audio signals. I'm going to go old school with this one. Anyway, so that's why we have this massive amount of filtering here. And why don't we start there? Might as well. All right, so standard cell and key filter. Let's see, this 68K to the negative terminal here. If this is an ideal op amp, you wouldn't have that in there, but Don's probably using some, what is he using? 4136. So that's basically like a bunch of 741s in a package, maybe slightly better, I'm not sure. These are all over the music easel. This is a quad op amp, but it's really annoying because it uses a non-standard pinout, or at least compared to more modern quad op amps. So what I typically do here is I use the 4558, which is electrically similar. So let me pull out a 4558. Let's go back to Eagle. Okay, let's add a 4558. Let's see if we have 4558. Let's see. Oh, you know, the 74 symbol had these little oval pads that I kind of like, but we'll go ahead and go with these round pads here. Sure, why not? Whoa, that's okay. I got not the version that I was looking for. Whoops. Okay. Off camera, Eagle had crashed. So I wound up losing my deletion here. So, whoop. It's not what I meant to do. Group is what I meant to do. Let's do that. Let's hit the delete key. Yay, and it deleted. Yay. Very exciting. All right. So what is it that we want to set up? Okay, I want a couple of op amps with the negative going towards the positive terminal. Let's see. So I'm running two screens, and I actually have a much bigger, or let me say it another way. The part of the screen that I'm capturing is a lot smaller than the part of the screen that you are seeing. So I'm trying to make sure that I don't randomly, let's mirror this. Rotate. And now let's copy it and paste it here. When I do that, oh, that is a new, yeah, see, I don't want it to do that. How do I do that without actually making a whole new chip? It's probably an easier way to do this. Whatever, I want the next one. Give me the next one there. Yeah, okay, so I'll have to mirror and rotate this one too. Okay, now negative is at the top. And let's see, okay, coming out of this first op amp, I'll have three 15K resistors. Let's see, add. Oh, actually, I have a resistor over here already for me. So I'm going to copy this. I'm a resistor. And let me put a bit of daylight here. Copy, doop. Let me fix the value here. So these are all 15K, right? Let's see. So if you watch the Ben Heck show, or that was the original Element 14 Presents thing, Ben, or you can watch the new Ben Heck Hacks. Amazing self-taught engineer. I think his actual background is in graphic design, and does a lot of really cool mods of taking game consoles and making portable versions of them and stuff like that. Anyway, one of, I think, his main skills and why he works so well in the YouTube video format is he has this DJ sense of never having dead air. Just whatever it is that he's doing, he can say stuff while it's going on. So there's never silence happening. I remember there are some capacitors in here. Let's see. This isn't a skill that I have. And he'll talk about times he worked at Funcoland or something. I forget. Some version of GameStop from the 90s or something like that. And let's see. What's on the original schematic for those caps? Those are all 910 picofarad caps. Let's see. Okay, so value. These are 910 puff. 910 puff. So Ben Heck, he'll also make a bunch of references to movies. He's constantly quoting movies while doing whatever else. Let's see. What? Okay, Don, what are you doing here? 1.5K in parallel 6.8K. This to me feels like he had it going and then had to add some kind of bodge. Either that or maybe he wanted a certain resistance and he happened to have these in his parts drawer. I don't know. 1.5K and 6.8K in parallel. All right, sure. Copy. Doop. Value. So this is, let me try to stay consistent. So what was the one on top? It's 1.5K. So I'm going to write this as 1K5. And the next one is 6K8. So if I was just doing this not recording, I would have, that on another, I would have the original schematic on another part of the screen. Actually, what we'll do is, value 1K5. So it's 1K5 and 6K8. And are these even, I don't think those even have a number. Okay, so I'm just going to call these, I'll call this RX1 because this wasn't part of the original schematic, and I'll call this, or actually, how about this? I'll call it something like R100. I'll call this R101 to kind of indicate these are not part of the original schematics here. Okay. Yeah, I like that. Okay, we'll do something like that. Yeah. How about that? All right. And I'll have to change those later anyway. All right, so what comes out? Okay, so that little network there connects to the negative input of the next op amp. So, yeah. Okay, scoosh this guy down here a bit. Want to draw an electrical connection here. And the resistor here going to ground. Let's see, that looks like that would be R32 4K7. Stick this here going to ground. Name well, I'm not sure what I did there. R32 value for, nope. Value 4K7. And whenever I'm doing name or value there, you can click over here, like here's name and here's value. Everything on the left here will map to a text command up here in this bar. And Eagle has a scripting language that you can sort of do text commands and make them all fancy. Where's ground at? Actually, let me delete the ground titles here because we know that's ground. Stick this down. Stick this down here. Now, what I'm going to do is I'm actually going to change the name here. I'm going to change this to OR32, making this an optional resistor. And then the reason I'm doing that is if this resistor here is there to deal with non-ideal op-amp effects, particularly non-ideal non-zero input currents that you'll get on something like a BJT input like the 4558. Now, if somebody wanted to try a TLO series op-amp, TLO 72 or TLO 82 instead, then those have JFETs at their inputs, much higher input impedances, and you flat out won't need this resistor. So sometimes sometimes I twitch a little when I see people, adapting an old design, like an old Buchla design, and they update the op amp, but without realizing that you can change, you don't need that resistor anymore. I mean, if you use a TL, if you have the resistor there, it doesn't hurt. I don't think it really significantly changes anything, but there's no reason to bother. So I'm just saying, if I want to indicate that if you are using a high input impedance op amp here, you could just replace that with a wire. Yeah, we'll need to connect this guy here, connect this guy here, connect this guy here. Ooh, I don't like that. That's ugly. Let's see if I group. I'm going to group because I want to scoosh this over. Now let's see, something I discovered the other day. Let me click to move. No, that just moves the thing. But I tried something else the other day. Okay, if I group all this and I don't click anything, I just click on this to move. I can't move the whole thing. Okay, Eagle joins the modern decades. Let's see. Let me make sure I'm doing this right. Okay, so that connects up through here. All right. Connect this here. And looking back at the original schematic, that goes to ground. So I'll copy a ground over here. Yes, make it connect to ground. So I should have mentioned earlier, and as you figured out, I'm just going to post this with somewhere between minimal and absolutely zero editing. So this isn't as refined as my 3084 or even my 4450 analog circuits for music synthesis lecture videos where I spend a lot of time editing. Okay, so we have a Salin key low-pass filter here, two-pole Salin key with 33K resistors. Doop. Let me move this trim pot template over. Like to move that over here. I'm going to have, let's see, what does a Salin key have? Salin key filter. And if you're in my 4450 class in the spring 2020 semester, this is the next filter to, no, actually, I think I'm going to do state variable filters first, and then we'll do Salin key. All right. And then there's a capacitor in the feedback loop of a Salin key. Let me move this over. Okay, so the feedback capacitance is 910 puff. The capacitor to ground is 220 puff. And, there's a 68K here in sort of this local feedback loop. Again, if this is an ideal op amp, you wouldn't need that in there. So I'm going to call this OR27. I should first make it exist. Control click to rotate. And let me move this down here. Name. Let's see. Net to draw a net wire. And OR27. Again, I think if you're using a high impedance input here, op amp here, you wouldn't really need that. What value is that? That was 68K. Okay, and let's see. You can't see it, but off screen, no, not name, value. Off screen, I have the original schematic, so I'm just going to go through here and clean up the numbers to get them matching with the original. R26. Let's see, this is R28, R29, R30. I don't have that DJ tendency where you can just, DJs, they just make noises with their mouth. They want to make sure there's no dead air. So you see 4. I try to, when I am putting together my lecture videos, I tried, I messed that up, didn't I? Okay, so the value of this should be 910 puff, but the name should be C3. No, where are you? Down here. Oh, let me clean. Oh, you know what? These aren't named on the schematic either. So I'm going to call this C200. Notice if I try to click on the name, it doesn't work because the name is parented to the symbol itself of the capacitor. So I'm using name and clicking here. We'll call this C201 because those weren't actually present on the... There's not an actual name on those on the original schematic. Let's see. What was I saying? Oh, anyway, when I'm putting together one of my lecture videos, it's a video format. So even if I'm using PowerPoint slides, I try to use animation on the slides, or I'll write on the slide as I'm going to make sure there's always something moving on the screen. Let's see. What's feeding this? Oh, outputs of various CMOS switches. So I have R23, R24, 1K. Copy. Scroll over here. Del, let's get rid of that. Let's see, and what did I say these were? These were 1K. Generally, people doing YouTube videos, lectures, a lot, especially with PowerPoint or even drawing, they'll have that little picture down in the corner and of a camera on them. I tend not to do that, partially because I'm self-conscious about my appearance on camera, and partially because then I would have to, bother setting up the camera and trying to make it look good or whatever and get the lighting right and everything. But mostly because I don't want people actually looking at me. I want them to be looking at the slides or the stuff I'm writing when I'm going Khan Academy style with the black background. Let's see. This guy has a feedback loop, feedback resistor and capacitor. I want them focusing on that. And that there is information in the person talking, but not as much. If you look at the MIT OpenCourseware videos, again, there is information in the body language, hand gestures, etc., of the person doing the lecture. But in general, I find that the camera person spends way too much time just showing the person talking and not even the person down in the corner or something, not enough what they're actually talking about. I think you could improve a lot of those videos if you went back and recut them and, took the person and made slides out of, let's see, C7R33. If you maybe took the big video of the person talking and made that be in a corner and then took the lecture slides and actually put those as the main thing in the video. And another thing you could do is you could maybe then do all sort of highlighting, whereas the person in the live lecture might be pointing to part on the physical slide. You could actually use your modern tool in Camtasia or whatever in order to highlight certain points on the slide. And just, or you could even take a case where the person has the whole, not percent. See, I'm trying to do that. I'm trying to do this thing of just talking to fill up space while I'm typing numbers. Me going, oh, and this is a 49.9 K1%. That's not terribly exciting. So I'm trying to say other stuff. And doing them both at the same time is actually very complicated. Let me make sure I'm actually named this. So this is name C7. Okay. Let's see. Shows, C7 over here. Wait a minute. No, that's not C7. Oh, I see the conflict here. So this should be C3. Just a second. Name. Okay. Name this one C3. Then we should be able to name this one C7. Anyway, what was I saying? Oh, I have a newfound appreciation for people like Ben Heck and DJs that can, be talking about stuff while working on something totally different. Anyway, what you could do if you were editing some of, say, those MIT OpenCourseWare, Stanford, whatever, is say the person who made the slides just showed the entire slide at once. You could go back and use the various tools in Camtasia or whatever to hide some of the information of the slides and reveal it slowly, as a lot of people typically will do on purpose when setting up the original lecture slides. Just anything to give some animation, because watching a live lecture on YouTube is kind of a miserable experience. So if you were to, anything you could do to add some animation to it of some kind, and I don't mean like animation cartoon, just stuff moving, because as humans, we're designed to focus in on stuff that's moving so the tigers won't eat us or whatever. And so I think when you're designing your, do I like that? Nah, it doesn't really matter. Okay. We'll go with, I think it was like that. Whatever. I mean, awfully persnickety. Let's see. There's a R34 680K. So just a YouTube lecture, or just a video lecture in general. You know, if you are watching a lecture live, I guess that's one thing. That's kind of neat. You know, if somebody's keeping track of the chat feed and is feeding questions to the speaker, that can be fun, I guess. But mostly I find watching a taped lecture on YouTube kind of insufferable. I believe it's very much its own medium. It's its own format, and trying to port what you do in a live lecture to a video lecture format is just going to be suboptimal. Now this guy here, is this a trim pot or is this a front panel control? I don't know. I'm going to use a trim pot for now, and then we'll do a grand accounting of the various. Because see down here, Don's being careful to label what the pots are. So for now, I'm going to assume this is a trim pot. So I'm going to go grab my favorite trim pot symbol. Oh, called actual trim pot. Let's see. Copy. This is from that template I had. Trim pot, trim pot, trim pot, trim pot. I am a trim pot. Do, 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 do. We are the trim pots. Do, 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 do. So one of the very bumful things about COVID is last summer, my son and I had tickets. We were going to go see Kraftwerk. And that obviously didn't happen. You know, they refunded everybody's money, but my son and I are Kraftwerk fans. I wouldn't consider my role as a father complete without introducing my son to Kraftwerk. And as far as concerts, so his first concert we went to was Imagine Dragons. And the very next night we went to see a band he really liked and I really liked called Marion Hill. And yeah, so I took him out 2 nights in a row when he was much younger than he is now. Probably not the most responsible dad thing, but he had a great time and we loved it. And we also went to see Queen. You know, Brian May is not getting any younger, so I figured there would be not many more. I spent a lot of money on those Queen tickets to get reasonably close seats, because I figure, you know, as I was saying, Brian May's not getting any younger. Okay, so here's a power supply, plus 15 volts. Let's copy that over here. Power supply. Okay. Yep. There we go. When he was much younger and I was playing Kraftwerk for him, at some point in the car, randomly, he was just in the back seat, and I heard him sing, "We are the robots, do 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 do, drinking chocolate milk, do 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 doop." Let's see if the ridiculous content ID system finds that through my horrible singing. All right, so that's all up there. Do 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 do. All right, and then there's another. Okay, so then 44.9K 1% R35. Whoop, no, that's not what I want to copy. Do, 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 do. 44 point, what did I just say? 49.9. Right, that's a decent resistor. Actually, I usually write this as 49K91%. Let me do that here too. I've mentioned a lot. This way, if you use the unit instead of the decimal point, if the decimal point accidentally gets lost at some point in the silk screen or whatever, it's the K is not going to get lost. And, you probably don't need a 1 to actually explicitly write 1% in here. Anybody building this will see that and realize that must be a 1% resistor, but let's be thorough. And I'm actually, for reasons I'll sort of get into later, because the circuit is copied twice, I'm going to leave this part here for handling later. All right, so what about the rest of this here? Oh, I do have some things that are unquestionably front panel pots. This is the K scaling factor. So what does K do? Let's see if I go back to the Flux Monkey website. K is the scaling factor on VA. So I'm going to use my front panel pot. Now, this is not actually the symbol for a... This is not actually the... Where's my schematic? There's my schematic. Now, I'm actually using a trim pot symbol for the front panel pot. And the reason I'm doing this is I actually want to be agnostic about what the front panel is going to look like, or if it's, 1/8" jacks or 1/4 jacks, or even bananas if you want to do the Serge or the Bug brand sort of thing. So I use a trim pot for front panel pots because it's a nice PCB footprint for putting in header pins, and then you could be agnostic as to what the actual... let's see, where does that come out of it? It's going to the negative terminal of this guy here. Oh, that's really tight. Do I like that? Oh, I don't like that. Usually I like to have some daylight here, but let me just do this. So usually I like to see some green there, but oh well. All right, and there's another front panel pot here that comes to this negative terminal. Wait a minute. Oh, I have this coming to the wrong spot. This doesn't actually go... Oh, no, it does. It does. Wait a minute. What am I... No. This... Let's see. Let's see, this trim pot here is actually coming out, the negative terminal of this final op amp. So it needs to go over here, actually. All right. And then, but what do we have coming out of here? Here, okay, so this goes to a... Oh, I see, the 10K really connects these. All right. Whoop, I did not mean to do that. Come back here. All right, 10K is connecting. It's really connecting this node here with this node. And actually, let me flip. Flip's not a command. Is there a mirror up-down? There probably is. Actually, let me get rid of the hooking there for a second. Let's see. Let's rotate. Because I want the wiper going this way, and let's mirror it because I want the arrow as you turn the knob to go the other direction. Right. Okay, and there's going to be a 91K resistor here, and I'm putting this on the PCB, probably in the original. And definitely, see the way there's this break here? That's Don's way of saying this is all on the front panel. So the way he would have wired this, or whoever was building modules for him, is this 91K would be on the front panel somewhere. I like to just put everything on the PCB and make it clear to me. So I'm going to give this a name. let's see, I think we had an R101 and I don't know, I'll call this R300. Sure, why not? Some big number to indicate that it's an off-board pot. All right, so this is connecting here. And this connects here. This connects here. All right, so the other, okay, so I have a 100K resistor here. Whoop. Copy this over here. And this is a 100K. Is there any indication if these are linear or log? No. All right. Oh, but, oh wait, that's not, this is a 100K 1% resistor. So this is 1%. Let me indicate that. Wait, value. Oh, okay. So the value is 100K 1%. The name, let's make the name, how about let's make this one 301 and this one 300. No particular reason. The value of this pot is 10K. I'm not going to put in a B or an A here without doing some further research of what that should be. We do need another pot over here. Again, this is a trim pot symbol, but I'm, let's see. So this one, the name, this is V offset. V offset. And it's a, oh, it's not indicated. More research required. All right. Okay. So here we have, this goes to ground. Now, you could put the ground symbol here, up like that. That tends to make me insane. So what I like to do, let's put this over here. All right. So what I like to do is I like to put the ground, not group, copy. I'll put the ground symbol here and connect over like this. So my ground symbol is still pointing downward. It just makes me happier to see it that way. You don't have to. If you want to have your ground symbol going up when it seems appropriate, like in this voltage divider where ground is the highest potential there, might as well put it there. You can do that. Okay, so I need a minus 15 supply. Let's copy that from over here. This is a minus 14 volt supply. All right. Make sure that's connected. It's connected. All right. Yeah. All right. Let's see. Oh, let's put in an input, our first input. Actually, before I do that, let me name this one. This one is K, I think. Yeah. Okay. So that's the K pot. We need a VA input. All right. So let's pull out one of the Aaron libraries. I'm going to do offset, or what did I call it? Offboard. I'm using the, whoa, no, that's not what I wanted. Offboard. There we go. So this is a symbol I made. What is this called? What did I call this? Offboard to Jack Alt _ Aaron. _ Aaron is a thing I just did. It's not because I'm stuck on myself. Although I could see how you might get that impression. Anyway, the _ Aaron is a thing I started adding just so I could quickly find symbols I added and differentiate those from all the other ones. Offboard means that this is a symbol I made to indicate that this is a jack that is not on the board. It's something on the front panel. And so we're just going to use header pins for the connections here. Offboard 2 probably meant for 2 pins, you know, signal and ground. I probably had an offboard 3 somewhere I lost. Alt means that this is a variation of some other one I made. But this, when I was sorting through all of my various homemade Eagle libraries, I couldn't find one that was offboard 2 jack without the alt. So I don't even know what that was. But anyway, this stuck. Let's see. So this is the VA input. Name, we'll call this VA. Hook that in here. Not V1. VA. So that's the VA input. And we also need a ground. Now, if we are really building this Buchla style, the control voltages will be done with banana jacks, and that ground won't even be used or connected. But if somebody wanted to build this MOTM, or I think MOTM and Moog both use 5-unit height modules, and they both use quarter-inch jacks, but there may be some differences in how they do the widths or where they put the mounting holes or something. Because I've heard of people talking about Moog units as a unit of width, the same way that people, why is there a K there? Okay, so this is the K pot. K9 kilo ohm, that's just whatever the K control is. All right. People talk about Moog units in the same way they'll talk about HP for Eurorack systems. Oh, that's ugly. Let me fix that here. Okay, let's put this here. Yeah, let's do it something like this. Oh, I like this. How about this? No, let's put the, no, that's going to be, I was trying to be unambiguous, and that would be pretty ambiguous. So let's just do that. We'll have the name and the value in the same row. Okay, so let me do some double checking of the original schematic against my schematic capture. I always thought that was weird. It's called schematic capture. Like when architects are putting in their stuff into AutoCAD or whatever it is architects do they call that capture? Are they capturing their architecture? Let's see. Okay. R25. Okay. 26. What's going on here? Okay. So the value of this cap is 220 puff. What happened there? And the name should be C4. So let me scoosh this over. Scoosh, 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 scoosh. Let me scoosh this. Scoosh, scoosh, scoosh. Scooshing. Okay. Let's see. So, okay. Oh, wait. I need to change these are 33K. 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 All right. C3, 910, 27. Hey, let's look at Lanterman read-off values from a schematic. How thrilling. All right. So through, okay. 28, 29, 30, all 15K. 910, 910, 910. All right. 1.5. 6.8K. What about, oh, yeah, let's 68K for 10 volt. I definitely want to do the 10 volt format. So let's change this to 68K. All right. So we're using that 10 volt. You know, if somebody wants to build, I guess, the 15 volt version, they can change that back to a 91 if they want, or just install a 91 there. Let's see. So I've got, this is R32. Let me move that over to clean up the way that's written a bit. Actually, let's do this. This will look nice, won't it? There's no real logic to what I'm doing here. If you're looking for any logic, sorry. Let's see, C7s, C40 puff. All right. And this resistor here. Oh, this should be, okay, this is R32, R33. This should be R35. So let's rename this R35. It's going up here, 68K, R34. Yeah. All right. And this goes up here Right. And so this is, what should we call this guy here? I'm going to call this, how about TP1 for trim pot 1? I don't know. I forget. I have a standard thing I like to call these, but I forget. I like to call things like trim pot something other than R. I like to, reserve R for things that are fixed resistors and call out something like a pot separately. That's just my preference. All right. That's as far as I want to go that way. And let's see. Okay. So what about the switches? What about the switches here? Switch. So I've got a CMOS switch here. And what CMOS switch is he using? He's using the 4016. Doot. Let's scoosh over here. Move all this junk out of the way. Why am I even keeping any of this junk? I have enough stuff to copy here. Can't help it. Anyway, okay. Got to move that. All right. All right. So I need a 4016. All right. So let's go back to the Eagle and add 4016 using Wildcards and see what we got. Quad. Wow. That's a funky looking symbol there. Molex connector. Memory. These are distinctly not what we're looking for. Okay, so what kind of symbols do we have here? Wow. Those are, what is that? No, this isn't, what is that? It's got these little jumper wires and the notation here is odd. All right. I like this. Okay. I like these guys. Oh, really important thing. Notice I'm very careful to select a package that's through hole because I want to build things through hole because surface mount scares me. And I could do surface mount if I really have to, but I would prefer not to. And I have to be careful not to do this. It will let you put this on the schematic, but then you'll be in pain when you go back to actually try to do something with it. And luckily it's complaining. It doesn't let me do that. Older versions of Eagle, or at least I've been in cases where it will let me put something like this on the schematic, and when you go to make a PCB, it's a problem because you need something with a footprint. Now, let me show you something you can do. So what I'm going to do is I'm actually going to do something with the wrong part that I don't want. And let's say we connect that here. And a little bit later I go, oh no, that wasn't the part I wanted. Well, there is is it replace? Yes, there is. So I can replace it with a part. And now if I click on it, did you see that? So you can only replace parts that actually have matching pinouts and basically matching names on the pinouts. Otherwise, it will complain that that doesn't really work, and you have to delete this and do it manually. But that replaceability has saved me on many an occasion. All right, so let's see, I've got, okay, so I'll add, okay, so the control pin here, So I've got 11 and 12. Wait a minute. That's not. Oh, 1, 2, 13. Oh, okay. Yeah. 1, 2. Let's attach pin 2 to the, and actually let me rotate it and flip it. Oh, there's no flip command. Mirror Lanterman. All right. So pin 2, I'll connect to 1. It doesn't really matter. I could swap, I could swap 1 and 2 here. It's a pass-through gate that's controlled. I can't obviously switch like 13 and 1 or something like that. All right. And then, actually, yeah. Okay, so let's see. Now, if I copy this, it gives me a new chip. Is there another? I don't. What I want is I want like the next gate from that chip. There's a way to do that. Separate name value, replace. No. There should be a way to just do that without actually having to use it. What am I doing there? Invoke. I'll invoke and use the next one. This is going to drive me nuts. If I, no. Oh wait, it did. I lost track. I'm not sure what I'm doing. I think I got confused because, anyway, I think I got confused. Now, if I copy this, does it give me, yeah, okay, I wasn't confused. It is giving me a new chip. What if I hold down some sort of command while doing it? No. Okay, that was the shift key. What if I try to copy it? No. What if I try to copy it while holding down the option key? What if I click and hold down the option key? No, none of that is working. I just wanted to give me the next thing in that actual chip. Huh. No, it's not doing what I want it to do. Anyway, now, yeah, see, it's giving me, this is IC2, this IC3, that's a whole new chip. I just want the next gate in that chip. There's a way to do this that I'm forgetting. I'm sure somebody in the comments will let us know. All right, so, yeah, so the 3, 4, 5, let me use that on the other 1K. And, let's see. Yeah, so if I want to put the 3 over there, let me rotate and mirror. Okay, so let's see. So I'll go put that. I like to do this because I do. All right, so connecting to pin 2 and pin 3. All right, and let's see, pin, oh, that's going to something else. Okay. So pin 5 here is going through a 22K resistor to plus 15. Okay, sure. Value 22K. What's that one called? It's R22. All right. Plus 15. Let me get a plus 15. I like to put it something like this. Sure. All right. And that connects to pin 5. And then it'll connect to some other stuff later. Let me go ahead. Let's see. The other gate used here is 11, 12, 10, 11, 12. Which one's 10, 11, 12? Oh, it's this one right here. I move that over. Nope, you are not connected. Let me just move the rest of you over here. Not sure why I'm keeping these around. Why am I keeping these around? Go away. If I need you again, I can find you. All right. Let's see. So 12, let's put that on the right hand. Let's see. Oh, let's see if 10, can I just rotate this? Okay, so we'll have 10 going downward, 11 going upward, and I want 12 on the right to kind of match that more or less. All right, let's do something like that. All right. That is my throat growling there. Maybe I'm hungry. All right. Oh, where's that silly bend thing? Okay. Ah, come back here. There we go. Ah, no, stop. All right. I don't know how to use whatever that tool that was. That goes up to pin 10. Okay. So I'm going to scooch this over here a bit. Okay, so that can go up to pin 10. Connected through like that. Pin 12 and pin 13 here are connected. Let me move this whole thing over. All right. So pin 12, where did you go? Yelp. Whoop, I went over too far. Pin 12 and pin 13 connect. Zoop. Zoop. There you go. Okay, pin 12 and pin 13 are now connected. Pin 11 here. What does pin 11 connect? Oh, pin 11 just connects to ground. Right, and Don just wrote a 0 here for ground. I'm going to do my usual thing of I like to come over and copy a ground symbol. We'll stick a ground symbol here. Wait a minute. Oh, if you're watching the video earlier, I started by putting some bypass caps here, but at one point when I paused the video, Eagle crashed on me and I lost that. I'll put those back in later. All right. So that's a ground. I prefer that than to having a ground going upward, which you can do if you want. No problem. It's just a matter of style. Let's see. And then I've got an R13 and an R12 coming to whatever's connecting here. Notice there's probably a more elegant way of doing this, but to kind of get more space here, I'm actually going to need a test point. I don't know. Probably not. I'll tend to zoom in on a spot and then back out. Let's see. R13, R12. Need to find a resistor. There you are. Okay, so I'll put an R13 coming out here. And an R12. Name R13. Name R12. Okay, R13, R12. Value is going to be 5K7, not 5.4. Why did I say 5? Value. There's a reason these are called late night schematic capture. 10K. And that goes to plus 15. So let's grab a plus 15 supply and we'll stick it there. Let me just move this real quick to make sure that connects. It does. All right. Do. Let's see. And there's a... Oh, so this bit of circuitry up here is what generates the triangle wave that the various other voltages are compared to, that the some threshold voltages are compared to generate the timing signal, the PWM chopper business. And let's see. So if this is common between both sections, I want to leave that separate for a second. And the stuff that gets copied, I'm going to experiment. There's apparently some new feature in Eagle called design blocks. Because one thing I've always complained about Eagle is if you design your schematic and then you lay out your PCB, well, if you have two sections of your circuit that are basically identical and you copy it in your schematic, there's no way I've found of cleanly just copying the layout on the PCB. There's sort of ways to do it, but then you can it's a hassle. It's a problem in it. It's very fragile then, at least I've found. So there's supposed to be some new feature called design blocks that lets you do that. And the Eagle Autodesk website makes a big deal of, oh, there's these new design blocks. Aren't they awesome? Like, Eagle should really have been doing this a long time ago. But I haven't actually used that feature yet, but I will later. So I'm going to assume that the way he's drawn this, that there's a separate D3 and D10 for the two copies of this circuit down here. So I'll go ahead and put in the resistors here. Let's see. Wait, what is that all hooked to actually? There's an op amp here. Actually, I've got two op amps. So let me do that. Got a couple op amps. Let's copy some op amps. Why do I keep carrying these around? I can get those back if I need to. All right. Let's see. So I have an op amp. The op amp output goes to that little juncture there. And then I'll need another one. So let's see. What op amp did I use? I used one of these. And put one out here. And then now, oh wait, if I do add 4558, will it then? No, I bet you it won't. Okay, nope. Got my hands off the keys there. All right, let's invoke the next one. What is the way to do that? There's a way to just have it. Now, if I just add 4558, I should be able to go. Okay, here's my 4558D. If I do this, left clicked. That's not what I want. No, that's what I want. Okay. Oh, okay. You know what? Okay, I think it's because I'm copying. If I just keep going, it will give me what I want. But anyway, I already had what I want here. So if you add, you just keep clicking for all the op amps you want instead of copying later. I think that's the way to go. There should be a way to do that the way I was doing it more cleanly without invoking, though. Okay, now let's see. This op amp, he has the positive up here. Oh, notice there's no negative feedback. He's using this one as a comparator. This one over here is being used in linear mode, so I'll do the usual mirror, rotate, rotate, and let's see. The output connects here. And let's see, there's an R9 and an R10 that are 1%. So, yeah. Okay, so here's for R9. Here's for R10. And those are, oh, I probably should have changed the value first. 10K 1%. So then the value would have copied to 10K 1%, 10K 1%. Doop, 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 doop. Actually, let me do this. I just like the way it looks better. This is purely aesthetic. There we go. R9, R10. And let's see. I'm going to leave R10 disconnected because this then is connecting to the part of the circuit that's common to both. Diodes. Okay, so he's used, if you want to go authentic, 1N417. So what I'm just going to do is I'm going to find a diode symbol I like and then just call it that. Actually, is there a 457 in there already? No, of course not. It's an older diode. I'm sure you could build this whole thing with 914s or 4148s. Let's see, there's different symbols in here. Now see, and this symbol of the schematic has all this junk here. What is all that junk? Let's see. What's Adafruit? Oh, you know what? I like Adafruit symbol for a diode. I highly recommend the Adafruit libraries. They're nice. Look at this one. It's got this nice, I like the way that looks. And it doesn't, for some reason, this one on the schematic, it's got a bunch of junk here. And notice we don't have to call it 1N4148. Let's see, there's another, I forget what it was. There's a small thing modular, has a small diode. Ooh, I like this symbol. Look at what's nice about this symbol. This is from the Music Thing Modular library. It has a, it uses a different pad for that's the cathode, right? Current flows from anode to cathode. And I like that. So let's try that. Yeah, so let's put that in. Where does that go? That goes to the, faces into the positive terminal of this guy. Oh, along with the rest of this. So let me move this over here. And yeah, let me add that small diode. So good on you, music theme modular. Because now when that's on the PCB, there will be this other visual indication of the pad size, of the pad being square, beyond the silk screen. So that's kind of nice. All right, so as with the resistor, I'm not going to connect this to anything in particular right now because that all comes from another part of the circuit. So this comes from here, these resistors and diode don't connect together. They come from different things. All right, so this op amp here, don't you like that diode symbol? I really like that. So many kudos to Music Theme Modular. That's a really nice symbol. I like that. Let's see. Okay, so this one is in, I thought I had already done this. Maybe I did it and then undid it. Anyway, for linear op amps, or for op amps operating with negative feedback in a linear mode, I like to do it like this. Okay, so we have 68K in the 68K in the feedback loop, 68K in the feedback loop. And what else do I have in the feedback loop? Feedback loop. Oh, I've got 100 puff, 100 puff, 100 puff. Oh, I've got 100 puff in the feedback loop. Let's see. 100 puff, 100 puff, 100 puff. There we go. Value. 100 puff, 100 puff. And, well, not value, name. What is the name? What is the name? Name is C2. Okay? NotCat. C2, C2. C2 already exists. Why are you C2? Wherever you are, I don't want you. So I'm going to back all the way out. Move C2. This is just, okay, you. Oh, let's call this C101. No, I usually call this like C100. And I'll call this C101. I have to click on the anchor. C101. All right. Do. Where were we? All right. Oh, no, I don't want to do that. Man, I'm bummed about Doctor Who because I think Jodie Whittaker is actually great as the Doctor. I just think she's being really let down with some terrible scripts. And I think the actors that were playing the new companions on the show were really good. And I just think they've been left out by some really mediocre scripts. And, there's been a few good, they have had a few good scripts and a few good moments, which makes me sad because then I think about what they could do if they were given better scripts. I mean, that was true, in Peter Capaldi's run. He had some great scripts and then he was given some clunker scripts and he's Peter Capaldi. So I want this to be name. He did a really fantastic job with some clunker scripts, but like there was that two-parter. The first one, there was that weird book that the Vatican, it was kind of like doing this Da Vinci Code, Dan Brown thing where there's this book that every time, where is C2? I thought I got rid of you, C2. Move C2. I thought I changed you already. What did I do something dumb? I did. I changed the value. I should go to bed. I shouldn't be entering schematics now. What silliness made me think that was a good idea? Value. This should be, what I usually make these? I usually make these 10U. These are the big electric bypass caps. What was I saying? Oh, so there was okay, now I want to change the name. Yeah, so there was this book, I think it was called The Veritas, I can't remember what, that people who read it promptly committed suicide, and it builds this big mystery, and the Pope shows up, and then Bill Potts, the doctor's companion, is really annoyed, and they built this. The episode was paced tremendously well. It was really well directed. No, not value. I want to change the value. I want the value. What is the value? The value is 100 puff. Value is 100 puff, and the name is C2. Anyway, that was a great episode. But then the second part, and these, it turns out the bad guys were called the monks. They were kind of like these zombie, like corpse-looking guys in robes, and they were manipulating human civilization or something, the development of human civilization, or they were being programmed. People were being programmed to think that. Anyway, that was followed up by a thing where there was like they came down in their big spaceship, and then they directly interacted with aliens, and that was, they're from another dimension. That was really good. But then the third episode, then the doctor was, he was pretending to work for them by making propaganda broadcast, and then they did this fake regeneration. That episode was just dumb. I'm like, you had this really great script, and then you gave a really bad script. Matt Smith, first 2 seasons, amazing. First half of third season, okay. Last half of third season, just mediocre scripts. So that's always been the case, but I feel like Jodie Whittaker and the folks playing the companions were really let down by some mediocre scripts. This should be 68K. All right. And what's annoying is a bunch of people are going to, it's going to get flagged as oh, the problem is there's a female doctor. No, the problem is not that there's a female doctor. The problem is that I don't think the showrunner knows what he's doing. Let's see. Yeah. Now, what I don't get is I haven't seen Broadchurch, but I've heard it's amazing. And so I don't quite get how somebody who can write a show as good as I'm told Broadchurch is. I haven't seen it, but people whose opinions I respect and who agree with me about the new seasons of Doctor Who would say that. It's like, so how could you be so good? I don't know, maybe, different writers, since this is kind of just connected there, I'll go ahead and do that. Different writers can play to their strengths in different ways, and maybe Doctor Who just doesn't play to his strengths. But the whole business of the timeless child and kind of retconning the dawn of Time Lord civilization, all that, man, that's just a mess. Because it doesn't really the thing is, I don't think they should ignore it now that they brought it out, but you sort of could, and it wouldn't really, change very much in terms of the kinds of stories you could tell in Doctor Who. I'm not sure what additional storytelling, potentials it goes. I thought Joe Martin was amazing as this other doctor. And it's not even that you shouldn't have some other potential doctors, secret doctors poke their head in, like John Hurt's doctor or whatever. But to have this whole retconning of Time Lord history, it's like, what's actually going on here? This doesn't actually make any sense. I want to do that. I think this, again, I'm just doing an aesthetic thing. Yes, combined to ground. All right, so what do we have here? Value. Oh, I should have copied it from up here because it was already 100 puff. Value 100 puff. 100 puff was the magic dragon. All right. Name R100. And when I'm just here by myself, well, I am here by myself, but when I'm not recording myself, wait, no, not that. Change this. This is the thing that should be R100. And it's 4K7. I do sing weird little things to myself. 4K7. And make little noises to myself. Some of them out loud, some of them not. Where are you? So that's R11. This capacitor is unlabeled. You know what that tells me? This was probably a bodge capacitor that Don put in after the fact. I'm just guessing. So let's call this R300. Yeah, sure. All right. Just to have something to call it. Wait, what am I doing here? Oh, the name here is R11. And the value is, the value is 4K7. I keep getting those. Okay. What? No. Okay. Name. What is the name? The name is R11. Value. What is the value? The value is 4K7. Whew. All right. So let me make sure I did that right here. Okay, the value is that. And then the name's the other thing. All right. Let me move the symbol here down here. Actually, you know what? Let's move this down here. I just think it will look better if I do that. You know what? Aesthetically speaking, I just want to move this whole thing over. Again, purely aesthetics. Zoop. It didn't do. Group whole thing. Oh, wait, no, I don't. I could just click on it right away and it will keep the group together. All right, I like that. I'll put R11 here, right? Because that's not going to be ambiguous about what that is referring to. D1, I'm going to later put something on the silk screen that says like all diodes are 1N457 or whatever. Although I'm sure this will work fine with 914s or 4148s or whatever. Just if you are a purist. All right. Let's double check that. Okay, so I've got, all right, 22. Let's play the game of watching Lanternmen look over schematics. Thrilling. Excitement. Wait, did I just connect those? I said that those were not supposed to be connected. These are not connected. Those should not be connected, right? Right, these are coming from different parts of the main clock PWM kind of sequence driving circuit. Two branches, those should not be connected. All right. Okay, I think that's all good. Let me move this over so that looks better. All right. I think I got all of that there. All right, so I'm going to scroll down here. Okay, I'm back with you after a bit of a break. I made myself a ham and provolone cheese sandwich with some mayo. Let's see. So I've got a 91K input here. Oh, but for the 10K, no, sorry, for the 10 volt control voltage, this should be 68K. So let's copy one of these resistors and zoom in here. So this will call, oh, actually the value I just said was 68K. If somebody wanted to do the original version, they could change this to 91. This one being a front panel front panel resistor, doesn't have an official name. Let's call it, I don't know, R500. All right. And then we have 100K here. That all goes, oh, wait a minute. No. I'm putting this in the wrong spot. Wrong spot. This should go to the negative terminal. All right. Do. Like that. All right. And then similarly, this doesn't have a name. Let's call it R501. Name R501. And the value here is 100K. Value here is 100K. And let's see, the input here, I need one of those jacks. Let me get one of my jacks. Mirror. This is an input. And let's see what comes in here. This is the M input. Name M. So that's the M input. And let's see. So this here, I think, corresponds to this middle knob on the processor here. So I think M goes in here, the M control signal, but you can also put an offset on that with this knob. So what should we call that? Excuse me. We should call that, oh, well, that's going to be called M, but I need a front panel pot. And again, these aren't actually actual potentiometer symbols on the PCB. What I'm using is a trim pot footprint that will use header pins on the PCB to go to our front panel. Let's see. Okay, so we need a ground. We need a positive supply. Excuse me. Put the positive supply here. And let's see, what value is this pot? This pot is, oh, value is not given. So we'll let that remain mysterious for now. We'll call this K. Oh, maybe we'll call it K offset also. It's this middle knob here to be consistent with the V offset here. This is like an offset of this. Wait, not K. No. K's over here. We'll call it the M offset. How about that? Something like that. Alrighty. Now we have our inputs to the CMOS switches. Okay, so I'm going to add, don't really need these anymore. Doop. Let's add 4558. That's the symbol we're using. And now what I'm going to do is I'm going to plug down two of these. So I'm going to plunk one here. And then I'm going to plunk one here. There we go. All right. These are in linear mode. Oh, they are being used with feedback mode, but the way Don's drawn them here, he has the negative in the numerator, the denominator. But this is the numerator of the op amp, and this is the denominator. No, he has a negative on the bottom. I'm just gonna copy some resistors. Do. All right. It is 2:25 a.m. local Atlanta time. Wait a minute. So what is that? R17, R14, 15. I bet you that's R17. Okay, so we'll call that R17. We'll call this R18, and we'll need we'll need some other resistors here. We'll need some. Okay, I'll put one. Copy. Making copies. Yeah. Let's move this up a bit. Okay. Copy this one here. And I have an input structure here. Copy going into the positive terminal. All right. Similarly down here. All right, these are going to ground. Pick up a ground here. This ground here. Ooh, that's getting a little smushed in. I'm not happy with that. Let's maybe move these out. All right. Okay. Just make sure this is connected the way I think it is. Let's see, these are going to a negative 15. So I need to pick up a negative voltage. Okay, copy that negative voltage thingamahoosit, and we'll put it here. And one goes there. Ah, that's close, isn't it? Don't like that. Let's see. What I'll do here. Oh, you know what? I like the idea of this going straight through like this. This just feels very appealing. Zoomp. Zoomp. Right. 22K to the plus 15s here. Right. And there's a cross there, but that's fine. And so I'll just take this V minus here and move it there. Because I do like the way, these look going over that direction. Okay. That's the feedback. Okay. Same thing down here. Yes, connect those nets. You almost always want to connect the nets unless you don't want to. All right, let's see. Let's see, that was R16, R17. And down here we have R20, R21. These are 18, 19. And up here we have, went too far, R14 and R15. You know what? I should have made one of these and then copied the whole thing. R14, R15. Is that what I said? R14, R15. Okay. Because now I have to do this again. Somebody told me there's a way to actually just set this. If I do like value 19K, will that just now work forever? Oh, there we go. Oh, okay. That's good to know. Yeah, let's see if I can use that here. So this is 49.9K 1%. So if I can do 49.9K 1%. Oh, I bet you that confuses it because I have that one. What if I did value 49.9K with nothing else? Ah, that it liked. But it looks like to do the 1%. Maybe I could do that, but put it in quotes or something. So because I think what it was doing was trying to parse it as a value name thing and then the actual value, which is why the 1% was confusing it. Okay. Yeah. All right. Oh, what are the actual values down here then? 49K and 20. Can I? I'll just do it straightforwardly. Okay. 49. Actually, I want to do the 49K9. 1% is how I do this. 49K9. 1%. Whoop. Yeah. 49K9. 1%. 49. I always like K9 on Doctor Who. That was, I guess you could say, one of the companions of one of the Tom Baker doctors. Like a lot of folks my age, my first exposure to Doctor Who was it being shown on PBS when Tom Baker was the doctor. Although later it was Peter Davidson, and then I think they went back and showed some episodes of John Pertwee. And then after Peter Davidson, it was Colin Baker, but Not that Colin Baker was a bad actor, but whatever choices they decided to have Colin Baker make were not. Basically, they had him act like a jerk. And presaged, to a certain extent, the way Peter Capaldi played the character, but I think they gave Peter Capaldi some more nuance. All right, so what about these 91. Wait. 10 volt version. So somebody can do 91K if they want, but let's do the 49K9 here. Wait, where did you go? Here you go. Name 49K9. Value. No. 49K9. And if it being 91K, did it need to be 1%? These don't need to be 1% either, but I think everyone will know that the only way you would be getting, let's just go ahead and put no need to be that much of a purist relative to the schematic, the original schematic. If you're going to buy these, they're going to be 1% resistors. So let's just go ahead and make that explicit. All right. So that's the input structures for the control voltages. And let's see what we have at the input. We have VB and VC. Let me get a jack. Oh, wait a minute. While I'm doing this, let me put this. Actually, let me just move this whole thing down. Click, drag. Click, drag some more. This input here needs a ground. Again, if you are building this Buchla style or Serge style or Bug brand style, these control voltages would be banana jacks because Buchla like to use bananas for control voltages, and they look like 1/8" jacks for audio, but they're really these things called tinny jacks or tiny jacks, and I think they're slightly bigger, so that's a complication. For Bug brand synths and for Serge synths, they use bananas on everything, and I think a lot of their Kirkpatrick stuff uses the Kirkpatrick format uses bananas for everything. All right, so why did I go up there originally? It was to copy that input symbol. Copying the input symbol. Let's see, we'll put one here. And we'll put it here. And let's see, this is VB, I think. And this is VC. Does something else get added? Something else gets added in here. So let me actually put some space in here. Let's get some daylight. This is VC. I'm going ahead and putting in the grounds in case somebody is building this MOTM or Eurorack style using 1/4" or 1/8" jacks. And this one has a switch. All right, so coming in here before this 49.9K, that's 180K. And, whoops, the value is 180K. I mess this up all the time. And this is, I don't know, let's call it R600. I'm indicating here resistors that are not, in the original circuit weren't on the PCB, but I'm putting them on the PCB because I like to do that. All right. Why am I doing that? That's good enough. I really like seeing green at these bends, but as you'll see here, I don't always do that. Let's see. So this goes to a 15 volt. Notice when I use voltages, if you were to draw it kind of the way Buchla did, you would have it like that, but I like to have just these going up the same way. I like to have grounds and negatives always going down. And we need a switch. So here I want a switch symbol. So let's go look for ones that are kind of, let's go look for a nice switch symbol. Oh, there's lots of switches out in here, aren't there? Switch, switch, switch. And this really just needs to be, right, this is all going to the front panel. Something like that will do. Let's see. Lots of switches. Those are all surface mounty switches. If I say, What's this? Tactile switch? Nah. So that was, let's see, what's the spacing here? That would be, if this is 0.1, that's more than that. See, these are for an actual physical switch on the board, but that's not really what I want. Oh, what about jumper? Let's see what kind of jumpers are here. Oh, okay, there's a jumper, but it doesn't really have a thing. What about shunt? I really just want two things next to each other. But here's the thing is, I would like to have something that looks like a switch on the PC, on the schematic side, even if it's just a couple of pads next to each other on the PCB side. I remember I was just looking, single pole, single throw. Ah, okay, if I do that, what do I get? Okay. Oh, these are all, sorry, okay, let's ignore those. These are all integrated circuits. Huh. I'm actually going to pause the video for a bit. Ah, here we go. So for reasons I don't know, when you search in the search field, it doesn't search for the library names. You have to have a part actually named with SWITCH if I were to try to search on it. So for instance, this EC12ESW, that doesn't show up if you search on switch. It doesn't look at the library names. Let's see, what are these? Surface mounting stuff. What are DILs? Oh, these are a bunch of DIL type switches. Let's go back to that if we really have to. Miss, okay. Oh, here we're going. I would like to have something that indicates, like something like this will do, but something that indicates that we really only need two pads. Do we have anything like that? Omron. Ooh, diagonally. What? Oh, these have LEDs built into them. Huh, that's kind of neat. Okay. What are Raychem switches? Oh, are these those like, I think these are like fuse things. Maybe? Resettable fuses, I think. Actually, can I drag this over? Yeah, so I think these are like fuses, like what they do is they overheat, but instead of blowing and just, opening up and needing replaced, I think they cool down after a while and you can restart your thing. Hopefully after figuring out what it was doing. Reed switches, okay. No. Let's see. Okay, if we did want to go with, nice. Let's see. Switch. There was a library here that just said switch. These are all slide switches. Let's look at rotary switchy thingies. That's kind of fun. Let's look at switches with Aaron Landerman. All right. Huh. Switches with LEDs in them. That's kind of neat. Oh, is this? I think the digital keyboard Synergy has buttons that look kind of like this. Is that what those are? Rotary switchy goodness. Simple switchy goodness. Sliding switch. Again, I just want something that... Oh, okay, that's simple and to the point. It looks like these all have 3. And I want to really indicate to the user that they don't really need to hook everything. Like if I would use this, if I really had a switch and I was using both sides of it. Oh, rotary switchy goodness. That's kind of fun. Ooh, look at that. That's kind of neat. Yeah. So I think the thing is a real switch is going to have 3 pins. Oh, except this, wait. Wait a minute. What's going on here? Here I have a thing with 2 pins, I guess, but this looks like those pads are shorted out. What is going on there? I don't know what's going on there. Wow, look at all this stuff. Yeah, okay, that's kind of, I like, those are nice little symbols for the PCB side. Do. Here's the thing. Okay, I'm gonna, I just wasted your time drastically. Yeah, so what was the thing that I called add Aaron? I'm going to use an IO pad. This is something I call that. Because really what I want to do is I really want to indicate to whoever's building this that that we're only using one side of the switch. So I'm actually going to call this, I'll just name this. And when we lay out the PCB, I'll put these next to each other. Now what does this switch actually do? It does some sort of offset-y goodness. Here. It says +5 switch. All right. Or plus 0.5. So let's call this plus 0.5 switch. And I'll call this A. And let me call this. See, I really wanted to put a little switchy symbol in here, but I didn't want to have 3 pins just because I was being ornery about that. I could have and just used 2 of them. You know, that's the way you would actually build the switch on the board, but I really want to call that out to the user. Plus 0.5 switch B. Actually, let me shorten this. SWA and SWB. And yeah, there we go. And I'll put this here. Let me scooch this over just a little bit. And, oh, let me do this. I don't know why I'm doing this. There's no particular reason for me to be switching these around. All right. Right. Can I just draw lines? Is there just a line drawing tool? Because if I just want to put a decorative line, draw a line. Oh, those are like fancy lines. I want like, let's see if I can do a different layer. No, because I think those are schematic. Oh, wait. Can I change something here? And this is just all, this doesn't need to be anything fancy. Name, place, names, values, symbols, plate, key names, values, info. Is this info? Yeah, okay, that does. So what I'm going to do is I'm going to, let's see, I want to draw, I haven't really used this in a while. What is all that? Is that some sort of simulation stuff? Straight, round, something like this. I'm going to draw in my own little thingy there to try to indicate that it's a switch. So there we go. Yeah, let me use a text tool. Switch. Just to indicate to the user what this is doing. Okay, that's the first time I've ever just drawn a thingy on the schematic randomly like that. All right, I just have to remember when I lay this out, these should go next to each other on the PCB. Although I guess technically they don't have to, but it would be very confusing wiring it up if that was not the case. All right, so that switches in, and I think, is that all the stuff associated with, I think, is that all the duplicated stuff? It's none of this stuff that's actually creating the pulse width modulation kind of style of signal. And I'm leaving out the part out here for a second, because notice everything else I sort of did in pairs. Here's a couple op amps, here's a couple op amps, here's a couple op amps. So I was able to do that all with duals. I think what I might do, once we figure out how to take the structure and copy it, hopefully using this design block business, I'll use another dual op amp for both of the things for that. So I'll handle that separately, and then we'll be building the rest of this separately anyway. One thing that feels unsatisfying is we're only using 3 of the CMOS switches. There's a 4th. We might, if we have space on this PCB, do something else with that. But I think that had all the main elements here. Just before I finish this part of the video out, let's put in some text here, and we'll say this is Buchla, what is this called? 257, and it's called the dual voltage. No, not the dual voltage processor. It's called the dual voltage processor. Okay. Processor. Adapted by Aaron Lanterman. And let's put that here, I guess. And I guess I should put a date on the schematic. Info. Let's use info on it to bring that back up. Come back here. I think I need to use, Shift Enter to go to the next line. Just hit Enter, it finishes it out. Let's see, what is today's date? It's April 16th, 2021. Going into the second year of COVID-19. Spectacular. All right. There we go. Yeah. So I think that's enough. Oh, what should we do with this for now? I'll come back to, did the Buchla specify in his? No, usually I forget what it is. There's a standard thing to do. Any multi-chip thingy any multi-part kind of chip, like an op amp or a hex inverter, will have a standard procedure, best practice of what to do with unused devices. And I'll either do something with this separately on the board, or I'll look up what that is, but we'll do that another time. In the meantime, we'll just have it hang out there. And there's probably some errors in here, but this is close enough for now. And I'll close this out here, and what we'll do is we'll start laying out the PCB, and then I'll see if I can try to use some of this design block thing to copy the structure, copy that PCB structure without having to do what you typically do, which is copy and paste this whole thing, but then when you lay out one part of the piece, we'll lay out one of them on the PCB, you have to manually go and do the same thing for the other one, which is always annoying. So I think I'll close this out here. Let's actually go to the board and just get a sense of how much stuff there is. Oh, no, wait a minute. This is not what I wanted. These are actual trim pots. I made a mistake. This one I was pretty sure was a real trim pot. This guy here. And it makes sense because we know there's 3 other knobs per control set. So there's 1, 2, 3. But these should be my other favorite trim pot symbol that has just 3 in a row. So let me pause the video and go look up what that was. Okay, I'm back. So let's use the replace command. And I found out the symbol I like to use for that. That gives me 3 things in a row on the PCB is this trim_US-B64Y. Let's see, so we need to do that to the offset, the M offset, and we need to do it to the V offset, and we need to do it to this K knob. There's the K knob. All right. So now if I go back to the board, aha. So now I have only one actual trim pot on the PCB. Might switch this one also. Anyway, yeah, so there's a PCB. Well, here's a space and here's some parts. And let's see, in the next one, next video, I'll start placing these on the PCB and we'll do some layout.